The riverbanks collapse, trees topple into the water, sections of people's yards crack apart and sink into the ground. The force behind this destruction is not a tropical storm or a flash flood. It is a fish. A creature native to South America has invaded the river systems of the United States and completely transformed everything in its path. This entire crisis did not begin with an industrial accident. It began inside the living rooms of millions of families. After watching this story, you will never look at the fish tanks sold in pet stores the same way again. People living along Brazil's São Francisco River have long been familiar with this fish. In some areas, it is called cai, while in others, it is known as cascudo. In the international aquarium trade, it is famous as the Pleco, commonly known as the suckermouth armored catfish. For years, this fish became a popular choice in pet stores. Because of one highly convenient characteristic, it constantly attaches itself to glass, decorative rocks, and submerged wood, scraping away the green algae growing on them. To buyers, it appears to be the perfect cleaner, peaceful, slow-moving, and extremely useful in almost any aquarium. Millions of these fish have been sold every year at very low prices. However, pet store labels often leave out one important fact: that tiny fish grows extremely quickly. Only a few months after being brought home, it can occupy a large portion of the aquarium. Not long afterward, it may exceed 30 centimeters in length and sometimes even reach 50 centimeters. A larger body means greater consumption. It begins uprooting expensive aquatic plants, producing enormous quantities of waste, clouding the water, and completely disrupting the balance of a small aquarium. The creature originally purchased to clean the tank becomes its primary source of pollution. Faced with an animal that has become far too large for an indoor aquarium, countless fish owners make the same decision. They take it to a nearby pond, canal, lake, or river and release it into the wild. This action usually comes from a humane intention. The owner believes the animal deserves a larger place to live. But a decision made in only a few minutes becomes the beginning of a chain reaction lasting for decades. Releasing a few fish into a river may sound harmless until you see how effectively they survive in the wild. This is how South American plecos crossed national borders and began thriving in North America. At first, there were only a few isolated individuals, followed by dozens, and then hundreds. By 2026, the latest estimates indicated that their population had reached tens of millions, spreading widely across states with warm climates. Florida, southern Texas, and areas bordering Mexico provide nearly perfect conditions for their survival. The water in these regions never becomes cold enough to interrupt their breeding cycle. But the decisive factor behind their population explosion lies within the structure of their own bodies. In nature, every ecosystem operates through balance. Organisms are born, grow, become food for other species, or have their populations controlled by locally adapted diseases. But when plecos arrived in North America, they encountered no natural enemy capable of posing a serious threat. This fish possesses extremely strong physical protection. Its entire body is covered with thick, hard, overlapping bony plates, accompanied by sharp spines along its fins. To native predators such as birds, alligators, and large predatory fish, plecos are not an attractive food source and can even be dangerous to swallow. With almost nothing hunting them, their population increases exponentially. But population growth is not the most shocking factor. The real crisis begins when researchers observe their reproductive behavior beneath the surface. During the breeding season, male plecos do not place their eggs on leaves or along the riverbed. They select earthen banks beside canals and begin digging. These are not shallow depressions. The males use their mouths and fins to excavate deep tunnels directly into the riverbank. Some of these tunnels extend more than 1 meter into the soil. Once construction is complete, the female enters to lay her eggs, while the male remains behind to guard them until thousands of young fish hatch. This is an exceptionally effective survival strategy that gives the offspring an almost perfect survival rate. Now multiply that burrowing behavior millions of times. This is not one fish, but tens of thousands operating along a narrow section of canal. The riverbank becomes filled with empty chambers, resembling an enormous honeycomb being hollowed out continuously. Beneath the water, the soil loses its structural support. The surface above may appear completely normal until heavy rain arrives or a passing boat produces a few small waves. The weakened ground eventually becomes unable to support its own weight. The entire riverbank collapses. Widespread erosion and subsidence are occurring continuously across Florida and have expanded into Texas river systems, such as the San Marcos and Guadalupe rivers. At present, water management agencies are spending tens of millions of dollars every year merely to reinforce collapsed canal banks damaged by plecos. The collapsing soil falls directly into the river, carrying enormous volumes of mud that cloud water once known for its clarity. Sunlight can no longer penetrate the surface, causing aquatic vegetation to die. When the plants disappear, native fish lose both their food supply and shelter. Anglers now pull up armored fish with hard scales, while traditional native species become increasingly rare. But if collapsing riverbanks and disrupted soil structures surprise you, the way these fish interact with some of the gentlest creatures in the water is even more disturbing. During the winter months, when ocean temperatures decline, manatees often move into Florida's warm inland springs to survive. Manatees are enormous, slow-moving, plant-eating mammals that are especially sensitive to cold temperatures. They must conserve as much energy as possible to endure the harshest months of the year. But these warm springs are now also heavily populated by plecos. Manatees naturally develop a thin layer of algae and protective mucus across their skin. To a pleco, the enormous body of a manatee resembles a moving rock covered with food. The fish begin attaching themselves tightly to the manatees' backs, sides, and bellies, using their suction cup mouths to continuously scrape away the algae and protective mucus. A single manatee may have dozens of plecos attached to its body at the same time. This constant scraping causes more than irritation and discomfort because it also erodes the manatee's essential protective mucus layer. To escape the fish, manatees must repeatedly shake, twist their bodies, swim faster, or dive downward before rising again. Biologists have recorded manatees being unable to rest for several consecutive hours. For an animal that must strictly conserve energy throughout the winter, every tail movement used to remove a pleco represents a serious waste of calories. This constant harassment leaves manatees exhausted and stressed and reduces their chances of surviving the cold season. It is a consequence that no one predicted when aquarium cleaning fish were released into canals several decades ago. This expansion is not stopping. What is happening in Florida has already been repeated in other states, and the lesson about removing an organism from its native home is continuing to unfold through even more astonishing numbers. The presence of plecos in the United States is no longer a localized phenomenon. Data through 2026 shows that they have expanded their range along the Rio Grande and pushed into freshwater systems deep inland across Texas. Control efforts are being intensified. Large-scale pleco fishing and removal tournaments are now being organized regularly. Thousands of individuals are removed from the water every weekend, but compared with their enormous reproductive rate, that number remains very small. A single female can lay thousands of eggs in one spawning event, and because the nests are dug deep into earthen banks and strictly guarded by the male, nearly every brood survives and reaches maturity. The story of the pleco is actually part of a much larger problem, the pet release syndrome. What is happening in the south with plecos is unfolding alongside a similar crisis in the Great Lakes region of northern North America. But this time, the species involved is the goldfish. Small goldfish, bought from aquarium stores for just a few cents, have grown in large lakes to the size of a football and can weigh as much as 2 to 3 kilograms. Like plecos, goldfish churn up bottom mud while searching for food, uproot vegetation, cloud the water, and create ideal conditions for toxic algae blooms. The tiny, glittering creatures that seem harmless inside a glass tank can completely reshape an entire food chain once they enter the wild. Both giant goldfish and armored plecos are clear proof of one thing: no organism is harmless when it is placed in the wrong ecosystem. More importantly, from a biological perspective, plecos are omnivores that feed on sediment and organic waste along the bottom. According to scientific reports released in 2026, the muscle tissue of individuals living in polluted waters can accumulate very high levels of heavy metals and toxins. Promoting human consumption of this fish as a form of ecological control therefore creates a major public health risk. Controlling an invasive species through the food supply chain is not a practical solution in the real world. You might think that after all the warnings, bans, and economic losses measured in billions of dollars, people would stop buying and selling this fish. Wrong. The strangest and most ironic part of the whole story is the underground pleco market is still booming, and it is even evolving in more unpredictable directions than before. Instead of trading only the original strains, the aquarium industry has started distributing high-value selectively bred variants, albino plecos, yellow-spotted plecos, and long-fin mutant lines. They are targeting consumer demand for rare and unusual animals, and the result is a continuing destructive cycle bought for appearance, rapid growth, overcrowded tanks, and release into the wild. The difference now is that humans are directly introducing fish with more complex bred genetics into the environment, fish that may be even more adaptable and capable of causing more unpredictable ecological damage. To be fair, the fish itself is not at fault. It has no intention of destroying anything. In its native environment in South America, the pleco plays a very important ecological role. In the São Francisco River, its burrowing behavior creates natural shelter. Its countless young become a food source that sustains predators, and the ecosystem there has evolved alongside it over millions of years. In that home environment, its population is controlled by natural predators, by changes in river flow, and by local biological cycles. The problem appears only when intervention takes place. Once an organism is lifted out of the place where it belongs and released into a completely unfamiliar environment, the natural rules that keep living systems in balance are immediately disabled. The change does not happen overnight. It happens quietly and slowly. It begins with a fish bought to clean an aquarium. Then a few patches of canal bank start collapsing. The river water gradually turns muddy. The old native fish disappear, and local wildlife is harassed to the point of exhaustion. This entire chain of events delivers a lesson that could not be clearer. Respecting nature does not only mean protecting wildlife from extinction. Respecting nature also means keeping species in their proper place. Every organism is one piece of a vast picture, positioned correctly by a very long evolutionary process. Sometimes, moving just one single piece out of its original place, even with the best intentions, is enough to permanently alter the shape of entire rivers. The ecological case file on plecos is one of the clearest demonstrations of human impact on nature. Removing a wild organism from its natural environment, placing it into an artificial one, and then solving the limitations of captivity by releasing it back into the wild is a process that runs completely against biological law. Ecosystems are not structured to automatically absorb or neutralize sudden alien elements. Changing the natural geographic distribution of a species not only disrupts ecological balance, but also directly causes the collapse of native food webs. This case study confirms one of the most fundamental principles of environmental science. Any human intervention in the natural distribution of living species, regardless of the intention behind it, carries the potential to completely destroy an entire ecosystem.